First Spin. Welcome to First Spin, a show where I learn how to use the parallax propeller without having any prior programming experience. Rather than do this on my own, I have enlisted the help of two experts. Hi, guys.
Hello.
Heidi.
So, on the parallax forums, I don't know if you guys know, but there's a new forum. And I was a little like, whoa, new forum. It's for the MicroMedic Contest. And we talked a little about it about beginning of December, I want to say, right?
I think that was true.
Yep. And then mid-January, so not too long ago, they came out with all the details. So if you go to learn.parallax.com/micromedic, you can see this contest, which is actually really freaking cool because I looked at some of the... Well, first, it's a partnership between the U.S. Army, Telemedicine and Advanced Technology Research Center, Carnegie Mellon Entertainment Technology Center, and, of course, Parallax. And you get to make any medically advanced thing having to do with, I don't know, I guess helping civilians, helping Army folk. And if you send in a good proposal and promise to do the project or do a project, they will send you a kit. Of course, assuming they accept you, they'll send you this really nifty kit with the prop BOE, which is totally worth it in and of itself.
They have two versions. So there's the prop BOE version of the kit, or there's the Arduino Shield BOE version. I'm just saying, to be fair, they have both versions. And they will be giving away the first 100 free kits. So
right.
Not unlimited, but
correct.
First 100 accepted proposals.
Yeah, but there's some really neat stuff, and as a nurse, that totally tickles my nurse brain.
Yeah. And they're also going to sell. They have the kits available on the store if you just want to buy one.
How much are they? Do
you know? They're a couple $100 for the Arduino one, and like $300 for the BOE one.
Yeah, what's the color sensor thing about? Is it to help diagnose if I've got sunburn because I'm so pasty?
No, but there's a couple of ways that the color one can be used, like possibly determining the color of fluids or blood or something. I don't really know for sure on all that, or possibly because I know they can use a camera to do pulse detection by putting your finger or thumb on the camera lens, like on your cell phone. So maybe you could use the color sensor with an appropriate detection of the blood pulses in your thumb. Like, I don't know if it's sensitive enough. Maybe that is one of the uses, but I could see it being like this is to cover all kinds of medical uses. So like, it could be something as sort of yucky as urinalysis, where the shade of the urine is purple.
That's
different. Like if
I've
there's
seen
blood
green.
in urine.
That was my morning today. Purple.
What? I've seen green and orange, like Gatorade orange. It's pretty cool.
So purple probably means you have blood. You might want to get that checked.
No,
well,
purple means you were taking a particular kind of medicine, actually.
Okay.
Which I wasn't.
I see.
So I
hope
sure.
not, because I don't think I have anything like that at home here.
I may be a purple people eater. It hasn't really been.
Yeah.
There actually is another new forum. They split out the Propeller 2 discussions into a new forum also.
Yep.
Now, is that color sensor capable of determining whether or not Addie did her homework this week?
I don't know.
Depends how hardcore I blush, but I
not.
probably won't. So, I will just admit it. I didn't do today's homework.
I think you did.
Well,
Sort of.
I kind of understand it. I mean, I understand the code, so that's a good leg up on the homework. But Whisker did a great deal of sitting there talking to himself and.
Well, I keep mentioning this, and you keep seeming to miss it. The point of working with this interpreter stuff isn't necessarily to make stuff with this ByteBite language, right? It's more to learn how it sucks, so that you can design something better yourself.
Yeah.
And
that's
really,
it's ridiculous.
Using this very limited, minimal thing, you'll learn the kinds of things you want to add to it to make
Mhm.
it not suck.
Mhm.
And that's what we want you, like I said last week, we want you to get to that point of what commands do you want to add to it.
Mhm.
And maybe now that you see this program, the new one that we're about to talk about, how complicated it was, maybe we could add a command or two here and there that would simplify it,
Right.
right?
Hmm.
Right.
So, last week Roy mentioned a couple of things that Addie could try her hand at, and she did. But it turned out that it was because this language is so absolutely brutal to try to do anything with. She did need some of my help to put together a little program in ByteBite to analyze, so that she could see where the weaknesses were. And I think in the analyzation process, she actually was able to understand it 100%.
Mhm.
So yeah, I'd say it's a complete win. We're going to post a link to the actual program with a step through of it. But the basic breakdown of the program that I put together for her is that it does what Roy suggested last week, which is to allow you to take advantage of the set memory function in the ByteBite host program, to store your strings right there in the program memory from the get-go. And not
Mhm.
just strings, but some other working variables too.
Mhm.
And it uses two strings, one at the beginning when the program is running and one at the end, to print out messages on the serial terminal to the user. The first message that it prints out is that it wants you to input a multiplicand
Mhm.
and to input a multiplicator.
Right.
Okay. And then it proceeds to actually do some multiplication using the absolutely horrendously difficult method that you have to do in this programming language to
Yeah.
actually do multiplication. It's literally adding up the number to itself multiple times. But to even do that, you need to create a nested loop situation, and there's no built-in way in the language to do nested loops.
Mhm.
So you have to be tricky. You've only got that one conditional statement. Is this zero? If so, do the command after the bracket. If it's anything else, do the very next command. That's the only logic you have. So I combined using that and using the jump um, instruction to hack around to create a nested loop.
Mhm. So are we actually going to go through this
No,
program?
it's not important for people to learn how to use ByteBite. What's important here is to learn how important it is to have cool, useful things that are easy to take for granted, like the ability to do nested loops,
Mhm.
like the ability to print out a string.
Mhm.
Yeah.
Now, the ironic thing here, I think, is that printing out a string in ByteBite is about the same as printing out a string in Spin.
Yeah, it's only a few characters. It's pretty simple.
It's very easy to do in ByteBite, and that's because we just did a sort of zero terminated string, just like you would do in
Right.
Spin.
And
It's
the
the easiest way to do it,
program,
really.
the full byte program to do this operation that Whisker just described is like 54 characters long, and the first 4 characters do the entire printing out of the message at the beginning, and then there's 4 characters right at the end that print out the second string. So a total of 8 characters in this does all the string printing, and then
Mhm.
all the other 46 characters are to do the math.
Yeah, the
Mhm.
math and the logic of the process of going the algorithm of using multiple additions to do multiplication.
So
And using a temporary variable,
Yes.
yep.
which is a key component, because what you will find in a lot of logic operations is the need for temporarily storing values, and the way most modern processors do that is that they have registers that you can store
ByteBite
temporary
doesn't have
values.
any registers or
Right.
accumulators, so you actually have to program virtual ones right there in your program, which
Yep.
is horrible, terrible. It
Right.
So
burns
technic
me.
so sort of technically, ByteBite has 256 registers at all of its memory
Yes,
that you
well,
just can make be whatever you want, and it's just difficult to navigate back and forth through them. So like one thing Addie might want to consider is maybe an easier way to directly access a specific memory address without having to just increment the pointer over to it or decrement the pointer over to it, but like going directly to it.
Yeah. Kind of like how we included that jump command, Addie, that allows you to jump to a specific instruction in executable memory. You saw how useful that became in doing this, right? Without it, it would be kind of impossible to do what I did.
Yeah.
But that kind of means that your case statements in the object ByteBite are more complex to decrease the complexity of the code you have to write.
Exactly.
I see.
She's getting
so you add more cases that have a little bit more fancy spin code inside of the case to do something more complicated for you. You write it once over there, and then you use it many times over in your actual ByteBite program.
So, and I know we're not going to go through this whole thing, but I did want to...
You're welcome to bring up any of the tricks that I implemented in its code if you're curious about them or if you thought they were neat or anything. That's fine.
Well, it's more, I wanted to explain a little bit of the setup of how you're supposed to read this little document. So the top program is just that long string starting from the open bracket to that closed bracket, like 54 characters.
And we're talking about the link for the explanation of the program.
Right.
Just to be clear.
Right.
I broke it down for everybody just to make it more readable because, man, oh man, are those programs themselves not readable.
Right. And then the memory string, that's something you put into the DAT section. You can pretty much copy paste what that is. And if you look at the 0, 46, 18, 0, 0, 0, 0, so that portion, the first 0, I think, is just like the 0...
to end the string.
Right. Whatever you guys call that.
Zero is, it's called zero termination or null termination.
Okay, null.
That's the terms.
Null termination then.
It's a delimiter.
Yeah.
Yeah.
Now what's F? What's that?
Those names, that was the F, the final.
Oh, okay.
Right, the 0 is the F.
So we're gonna simultaneously look at the memory aliases. So S1 is that first string 1. The input multiplican, hit enter, input multiplicator, hit enter. F is 0. J1 is 46. J2 is 18. X, Y, Z, T, S2, they're all the zeros. Or, well, S2 is the product, right? So T is like the total or technically the answer. X, Y, Z are used in the multiplication process. J1...
X and Y are the two numbers that you input to actually be multiplied.
Right.
And then Z is your temporary variable that you use while multiplying, and T holds the end result.
And these are just aliases I used for writing down the notes as I was working on the program.
Right.
Internally, ByteBite does not care what I called them in my head.
Right.
Right. This all makes a little more sense if you are actually following along on the explanation link.
Indeed.
Right.
I feel sorry for you if you're driving. This episode is going to be kind of rough.
Yeah.
So if in the code it gets to the J1 section, you'll end up going to 46. And 46 is the command number 46. So if you count from 0 to 45, or 40, is it 46 actually?
It's actually the 47th entry because 46 equals, starting at 0, the 47th.
Right. So you count from 0 to 46, and that's the command that you start from when you get to the J1 section, and then J2 you start at 18. So when you guys, if anybody actually takes the time to go through this, then
one thing we should maybe just discuss a little bit, because we actually kind of went over talking about it last week, was the nested loop mechanism.
Okay.
Sort of. The line in the explanation, it's the line right before the J2 label, which is, it says if, on the description next to it, it says if memx equals 0, then jump to J1, else jump to J2.
Mm-hmm.
So that little sequence there is
And
how
just cut in just for a split second here, Roy.
yeah,
That's explaining it in words that most of us would understand.
right.
For those of you driving who can't look at the code, that's open bracket less than lowercase j close bracket less than j.
I hope they're not
Everyone
listening to
following
this.
along?
I hope they're not listening
It's
to this on like a
terrible,
road
right?
trip.
It
They'd
is
end up starting to
terrible.
doze.
Well,
Do not
I was
use
actually
this language, people. It's evil.
right. So, like what Whisker just listed out there, I wanted to kind of explain. That's how he used the single conditional to decide whether to jump to one place or another place, because the open bracket is going to check for wherever we're pointing at currently. If it's a 0, it will skip over what's in the brackets and do the second jump. But if it is not 0, then it will go inside of the brackets and do that jump. So that's how it's choosing 2 different jump locations to go to. And then those 2 different, one of those jump locations is a loop, and the other one is jumping out of the loop.
Correct.
So it's technically it's just one loop. So it's not like at a higher level, we're just doing kind of one loop, but there's that outer loop is that mechanism. And then inside, when you're in the J2 section where it's doing the math, there's a couple more loops. So that's how we got nesting. Those 2 loops that are inside there doing the math are technically nested inside of that outer mechanism, which is doing those 2 jumps. So that's the trick in ByteBite to do nested loops the way we currently have.
Roy finds himself slightly attracted to me now.
It is quite sexy, that mechanism, I have to say.
My.
But the thing that why I wanted to kind of go into this is like, this is something that we might want to add a command to make this a little cleaner into ByteBite. Like that one, you might want to think about ways to maybe do that where it will take less characters, because that's taking 7 characters to do a standard common mechanism. You know, if something, go here, else go there, is a common kind of thing. A very like that's like fundamental in programming. You do that all the time.
Yeah.
I guess I just don't know how I would end up writing it in the case statements.
Well, that's where we can help you.
That's where the learning's going to happen.
Exactly. So we can help you with all that. It's just like one of the there's 2 things, right? You got to identify the problem that you want to solve.
Interpreters.
And then, well, no, I'm saying identify the specific case. Like in this particular case, we have these 7 characters that are, you know, if the result is 0, do this, else do this other thing. We could maybe turn that into one thing that you could put in, or at least something simpler with less characters, so that the program would be simpler and easier to read, right? And just identifying that, then you start thinking about, well, what do I need to do and how do I do that? And we can help you, and then you can add the command to the case statement and try it out and see if it works or doesn't, and then we can edit it. You know, we can do an iterative process. But you know, there are several, I mean, just in this one program, there's, you know, at least 2 or 3 things that could be turned into a command.
So the one under J2, does that make sense to turn that into command? The move MY into MZ while adding MY to MT?
That's totally the sort of thing you'd want a command to do, yeah.
But how would you, I don't understand how you would write it, though. I mean,
well, the thing that, what I would think about is that's the place where it used a temporary variable, right?
Yeah.
So maybe the thing that you want to think about is this could be enhanced by having a command that let you access a specific memory address instead of having
one
to
that's set aside ahead of time and is part of the interpreter itself.
Right.
An accumulator.
Right. So you could have a predetermined thing that's called the accumulator, and instead of having to have a memory address that would be T to hold the result, you
Z
could just
was our well, T is our accumulator, I guess, but Z is our temporary.
Yeah, and so like so we could have the accumulator, but we could also maybe add a temporary register that could hold a value. and you could use that instead of having to navigate, and then might simplify that. And then once you've simplified something, you might look at it again and realize, oh, well, now that we have registers and an accumulator, we can simplify it even further and make a command that just uses those directly.
Mm-hmm.
Right?
So
So you might have a
to lay that down a little bit, because
right.
it was a little bit thick there.
Right.
The easy way to do it in your interpreter is to have a command that just increments a variable that's part of the interpreter rather than being held in memory.
Okay.
Does that make a little more sense?
No.
If you've just got a command that, like, our plus sign increments whatever we're pointing at in memory,
Yeah.
we just can add an increment and decrement that work specifically on a predefined register that's not part of our memory address space. It's just its own variable stored in the virtual machine there.
Okay.
So
and then that can be moved into other places. So you'd also want a copy command, to copy that register over into memory to make it useful.
So as an example, like we didn't use the open parentheses and close parentheses at all.
Mm-hmm.
So we could assign the open and close parentheses to be kind of like plus and minus on a variable that's just built in instead of on the memory. So you could say that the open parentheses, since it sort of bends in the negative direction, subtracts 1 from the accumulator,
Mm-hmm.
and the close parentheses adds 1 to the accumulator, and the accumulator is just a built-in construct inside of the interpreter. So you would just have in the spin code, you'd have a variable called accumulator. You'd initialize it to 0, and then whenever they use the parentheses, it would just change that variable internally inside of the interpreter to increment it or decrement it. And then you could have a different command, some other character that we've not used, percent or and or whatever, just some character that's unused, that takes the accumulator and does something with it, like copies it into the current memory address.
Mm-hmm.
So that would then allow you to do the math there
Another
slightly
obviously
differently.
And another obviously one would be maybe a command that resets the accumulator down to 0.
Right.
Mm-hmm.
Or sets it to the value that you're pointed at in memory.
Mm-hmm.
These are all things that would be very useful to make math much, much easier.
See, so like the loop that decrements y and adds to t, right? Could it wouldn't like if it were just decrementing one variable and adding it to another,
Mm-hmm.
like or the second loop where we're moving z back into y. Let's just do that one because it's simpler, and I don't want to complicate the other one too badly. But you know where we're moving z back into y, that could be reduced to a minus of you could use the parentheses to decrement the accumulator, and the plus to increment y, and then if we change the brackets to be a different command that use the accumulator instead of the current memory address to check. There's a lot of things to think about. Then that loop would be less characters.
Couldn't we use like actual words too instead of
the problem
character
with using
symbols?
Right now everything is a single character does something. In here.
Yeah.
If we wanted to change it to be multiple characters does something, then we'd have to add additional logic to the interpreter to read a multi-character symbol as a single command.
You've heard us get into arguments about things like delimiters on the end of C++. You need to have a semicolon on the end of it.
Yeah.
Compared to tabulation in Spin, is what makes all of that happen. That's the sort of thing that you would have to build into your interpreter. It would need to be able to read that to figure out where a command started and where it stopped. And that we're building up to that. That's where we're driving towards at 99 miles an hour. Okay. That's where we're going. We're going to show you how to do that. But to get to that point, you need to learn how to do this stuff first so that when you do that stuff, it's freaking easy.
Right. So I think the best approach is, just to say it a different way, is let's add a few commands that are just single characters to the existing one so that you can get a feel for implementing new commands. And then later on, after you're comfortable with that, we can go into, well, now we've got to restructure it so that your input program isn't just a string of single characters, but is actually more like an actual spin or other program language where you have delimiters.
And in spin, the delimiter is the tab space.
Right. And the carriage return.
Carriage return at the end of a line, and tabbing in helps you, move in underneath a command above, meaning do this stuff underneath it, or if it's at the same level, it does it after it, right? So we'd have to come up with something for that. And that's pretty much necessary. I mean, we could hack something in to allow the current thing to work where, if the character sequence happened to be this 2 or 3 character long thing.
You don't want to do that, though.
But
that's just nasty fast.
That's just not a clean way to do it. It's just much better to...
The next step up from here, Addy, is to do something like having your commands be a set of 3, right? So you've got your command, and then it's followed by 2 more bytes, right? So you've got a jump command, and then you've got 2 bytes that follow it. And those are options that change how the jump works.
Right.
So depending on what the first one is set to, it may behave differently. And the second one may be literal addresses in memory, for example. So you could just have it right there in the command that it'll specifically jump to a particular address, which would have saved like 80% of the work out of this program here that I made.
Right.
But we don't have that functionality built in yet. It would be great if we did.
Right. And then another thing that kind of thing could do is you could have a copy command, which would be like copy from this memory address to this other memory address. And that's copy with 2 bytes, and the 2 bytes are which ones to copy from where.
Makes sense.
Right.
Yeah. Much easier to program with. Much easier.
Right.
And we can do that kind of stuff pretty easily in the current thing.
By the way, Addy, the thing that we just described that sounds much easier is basically what PASM is.
Assembly language. It's assembly language, yeah.
That's cool.
Except that instead of single characters, it actually has keywords.
Yeah, it has a lot of extra fun bits that make it easier to use. So,
right,
like you can use names for things rather than just numbers or symbols.
I'm doing like a sub-PASM.
Right, which will make PASM really easy when we get there.
I see.
Yeah,
exactly.
That works.
We're gonna have you being a PASM expert in like a year.
And we'll do it in the context of first spin because we're clever that way.
That's right.
Not quite as clever as my little my nested looping thing there, but
now
it's kind of its own nested loop, I guess.
We don't have much time left, but I wanted you guys to explain a little bit this @end string minus @trial3m.
Oh yeah, that was Roy.
You guys seem to be real pleased with yourselves over there.
No, that was totally Roy, not me.
So in the host program, this is a little thing that we did to load up the memory so that those strings, the reason we couldn't use the same loop that we did for the program is because the loop we did for the program that copies it from the trial section in the DAT into the program space, which has the 256 entries so that it can copy it into the ByteBite program, which expects 256. For the memory, we wanted to have zeros in the middle. So we can't stop at the first 0. It won't work. It won't fill in all the memory.
It'll go, oh, okay, I'm done now.
So what I did is I decided for memory, the first byte in the trial, in the memory DAT section thing, the first character or byte is the length of how many characters to copy.
Goodbye, delimiters. Hello, length-based strings. I love it.
So I started to just count how many characters were in that whole line, including all those comma 0, comma 46.
Where it was all like 1, 2, 3. Oh, I'm frustrated. I'm gonna do this better.
And then I was like, this is silly because if we go change this to have different strings
Roy
or
will be going again. 1, 2.
hey. So I was like, well, let's take advantage of a feature in Spin to help the compiler itself. So what I did is in that first byte, I put the label. So first of all, I put in our line of all the memory variables with those strings and the numbers. And then on the next line, I added a new label called nString with a byte 0. Right? And that's just the 0 that would be the null terminator for that second string. It's just on the next line. Then you can see in there where I do the nString minus trial3 mem. So that's the compiler will take those two addresses and subtract them from each other and give you the length between those two values.
Okay.
Right? And it works out because, and this is the little offset. So the two values subtracted from each other are from where trial mem is at in memory to where nString is at. And nString has the 0 and trial mem has the length. But the length of the actual string plus the 0 is offset by 1. But it works out because I do the subtraction of those two, and it's the length of the line, the data that's on the trial mem line, right?
Yeah.
Which is however many characters that is. I didn't count it.
And why I'm feeling a little attracted to Roy right now.
But you subtract those two things from each other, and it gives you the length of that line's data, whatever it is in there. And so then I use that value in code. So I didn't have to count anything. I just have those two. I let the compiler do the counting for me. So up above in the little loop there, it just uses trial3 mem sub 0, which is that first entry, as the index from 2 on the repeat loop, right? It goes to trial mem 3 sub 0. And then inside the loop, when it's copying from trial mem 3, it's using index plus 1.
Yeah.
So it'll copy after that count of how many, copy all the string and all the numbers and that trailing 0, which is on the nString line.
Very nice way to handle it.
Memory.
Very hackish and strange, but cool.
Well, but it's the using the at nString minus at trial3 mem is kind of a nice feature of the Spin compiler to know about, that you can take addresses and do math on them to figure out the sizes of things.
And the reason why Roy knows tricks like this is because he's the guy that wrote the C++ compiler.
Yeah, the converted from assembly version.
Yep.
Yeah. And I learned all these little intricacies of how the thing works. Handy. And some of the stuff a lot of other Spin programmers know because it's in the manual. If you go read it, there's places that talk about this stuff too. But I actually found this via the compiler conversion project. I had never done.
So there you go, folks. We got a contest, 2 new forums. We've got some absolutely terrible ByteBite code that you should never try to write.
I think you guys really like, actually.
It's fun in a masochistic way to do.
Right.
Yeah. It's good to learn how to think about it at that base server level, right? So it's good to know how to do it, but it's treat it more like a brain teaser than something that's, useful, because it's really not useful.
And I've been doing a lot of PASM assembly lately, so my brain is in that mode of thinking at that low level. So it's kind of cool and fun to play around with.
And we've got a nice little trick for how you can use the DAT section to do strings and include zeros, which is handy. So that's pretty much it for this week. That's all the time we have. We're actually running over because, it's hard to fit this show into 30 minutes. But we did our best. You guys can find this show every Tuesday evening at firstspin.tv. You can listen to it right there on the page, or there's also an RSS feed if you want to have it automatically downloaded to your phone, iTunes, whatever. Listening to this show in the car may be hazardous to your health, or at least your ability to understand what the heck we're talking about, because usually we're talking about stuff you got to read too. But you guys are welcome to listen to it on the road. We like driving with you guys.
Mm-hmm.
All right, we'll see you guys next week.
Bye.
Bye.
Bye.